I work next door actually in MongoDB. We have about 15 technical staff, primarily in technical services. We work with customers, you guys who work on the support side and some part of proof of concept generation. So I'm going to talk a little bit about some of the things I've learned as I've, over the last while, started to move into Python. So I'm definitely not a Python expert. Compared to some people here, I'm relatively new. For those who are just joined, I'm one of those people that Naomi talked about earlier. Probably better known here as someone who talks about R. So I started my migration from R into Python. Firstly, I should, I guess, define a few things. So when I talk about data pipeline, I'm talking about putting together the various stages where you move and transform your data through a pipe. It allows, various stages allow you to generate models. You might have a pipeline in your organization to create a dashboard. You might be looking at creating a data service or data product. Now that's an increasingly common sort of use for all of the tools and software I'm going to talk about today. And for those of you who don't know, so I work for MongoDB. It's a document database. It's high performance. It's scalable, and it supports a whole range of use cases from e-commerce catalogs to real-time analytics to dashboards. So some people come to us and say, right, I have all my data in MongoDB. How do I get it out? How do I make sense of it? I'll talk a little bit today about some of the tools in MongoDB, and I'll also talk about how you can move it from MongoDB into Python, how you can manipulate it, and how you can then train models off it and use it to create your dashboard or your service. One of the things I found in preparing for this talk was a very interesting blog post by Thomas Redman and Bill Sweden. Actually, just one point I forgot to say in the first slide. I do have a GitHub repo set up. It is empty. So if you furiously are trying to load that content, it will be there Sunday or Monday. And the deck will be there as well. It will also be in SpeakerDeck or speakerdeck.com/Praz. If some of the concepts I talk about a little later in the talk on machine learning are unfamiliar to you, I have some introductory talks up there on machine learning, and you can look at those. I'm going to gloss over those because today I'm going to take a page from those two gentlemen who, Redmond and Sweeney, who spoke about the needs in organizations for kind of two groups or two teams. So often when we hear presentations, we're looking at the laboratory side. So they spoke about a laboratory group, which involved pretty much what you'd expect in a university or an R&D company. So these people are the ones who are exploring, investigating, visualizing your data. They're creating models, but they're really testing hypotheses. And they're looking at, we have this interesting data set, where can we find value for the company, or where can we create a competitive advantage? So if you're looking at doing demand forecasting, so you know what your company's going to be next month, next year, those kind of things. Or whether it's just a real-time dashboard saying, okay, I'm selling all of this, and my VP of sales wants to know, how many t-shirts I'm selling. That too. But once you go into that sort of real-time sort of business side, you're moving to a different requirement. You're looking at what they call a factory group, and you're talking kind of about productionizing it. And I can see Peter nodding away because you're talking 2 o'clock tomorrow about that, aren't you?
Yeah, data, the productization of data knowledge and how you do that.
So I think your talk is all about success stories and learnings.
And a few failures too, but
so there's plenty of failures because it's this kind of bridge between people who might have done a PhD or might be working on something interesting in the lab and try and take it to production, The systems folk here in the room will know that there's a whole host of other concerns. I'm going to touch on a few in the talk, but there's hundreds of different other concerns you need to take into account. When you run something on your laptop, it's great, it works. Maybe you even run it on a single EC2 instance, it's great, it works. But when you try and manage hundreds of workflows, or hundreds of models and dashboards in a large organization, as your company scales up, you're in a very, very different place, and you actually need data engineers. So you need guys in the factory group who are solely concerned about providing a service. So Brian, actually, in a former life, was a site reliability engineer for Google. That whole role is where you look at your service, you look at it in production, you look at the various things you need to be concerned about: monitoring, you need to be concerned about consistency, scalability, repeatability, as opposed to scientific repeatability. And I'll talk about that in a minute. One of the things coming to this from that sort of production side, of kind of deciding on talk about some of the concerns, is the biggest problem moving models, whether they're R or whether they're Python, into production, is how do you manage them. One of the tools that many companies have developed or redeveloped or iterated slightly differently on are workflow. So if I have a model, how do I run an ensemble? How do I look at several of these together? How do I manage some of the concerns around that? So just to move on and quickly overview what I'm going to talk about. So I mentioned schedulers there. I'm going to talk a little bit about one in particular. I've looked at one that I found very easy to use. It came from Airbnb, and we'll talk about some other ones. It's called Airflow. So there'll be some code samples you can get up repo after the talk as well. You can look at this. It's incredibly easy to set up, so you can do this on your laptop, and then you can look at using remote schedulers and using those. But for all of the stuff I just did it on my laptop, so it's quite easy to do some evening. Moving beyond that, I'm going to talk about the various systems, the fundamental building blocks. So, obviously I work for MongoDB, something I'm really familiar with. I'm using Python a lot. So we're building internal pipeline. We have a cloud service where we monitor and do administration for your databases. So we have a lot of data that we're analyzing. We're building our own pipelines internally to provide value add. So one of the things I do day to day is we detect anomalies and we reach out to customers and say, actually, your production cluster there is doing something rather bad, or it could be going somewhere bad. Maybe you should look at that. Something that's kind of new to us, but it's kind of a logical development of our monitoring system. So that's kind of my own day-to-day a lot. But also I've worked a lot with customers in the past, and they've asked similar questions. Moving into the I guess one of the things we sometimes get hit with, how do I make it faster? I really want this to be done in as short a time as possible. One of the things you might encounter if you use MongoDB and Python is you typically use Mongo. Mongo is a great tool, but it has some limitations, particularly around the volume of data it can transfer. I'll talk a little bit about that. But speed is very important in these production pipelines. If you're doing a real-time analytics dashboard, you need the data. If you're a model and you're regenerating it frequently, if you have a large data set that you train that model off, you need to push that information to Mongo quickly. So one of the things I hope you'll take away from this talk is some tricks on how to move data from MongoDB faster and how to use some of the tools within it. But also, I've kept this all Python. You can look at various other tools around some of this, but the focus, because I'm learning more Python as I go along, but I wanted to keep to the tools that just use Python. So that was one of the reasons why I picked Airflow. Airflow has one approach to generating its objects but they're all defined in Python. So if you're used to Python, it's very simple to just add these in, and there's no really unfamiliar syntax in it. There are a number of typical challenges in an operational pipeline. So one of the things you'll always hear if you're new to data science or you're new to data analytics or however you want to label it is dirty data, missing data. So combining, cleaning, formatting that data is really important. In fact, this is where you go to the lab group. You'll hope at that point they'll have cleaned up the model so that it's a little bit more robust to take dirty data. But on top of that, there are other challenges. So if you want a pipeline that's continuously running or hundreds of jobs running, you maybe want to break those up into workflows and manage all of those. You need to be able to monitor each of those. So I'll give actually Brian another plug because he's just started up a company and he's going to talk a little bit this evening at 5:30 in the lightning talks about one monitoring tool, Prometheus, which is a push or pull monitoring tool, which you can instrument your code to send the information out to, but you can also do some other neat and tricky stuff. I'll let Brian talk a little bit more about the monitoring side, but if you don't monitor your pipeline, you don't know your high or low sort of time marks. So do you need to add more capacity? Is something causing a blockage? How long is the entirety of the pipeline taking? And how long are the individual segments? So not to sort of steal the Netflix mantra, but instrument everything. It's very useful to have all of that data. Even if you don't need it now, having access to it is very important. And working with things like Python, which have exporters to Prometheus, the other monitoring tools is really important. So that was another reason to stick with Airflow. One of the other, I guess, final learnings I've had from my own career is we often have questions about why isn't this working faster? So on top of all of these systems, you may be running an EC2, you might be using MongoDB, you might be using another database. My pet peeve is people not reading the docs and implementing the simple things like our production notes. When you move from a lab environment, you're being set up on your laptop, but moving it to a public cloud environment, you need to be aware of whatever operating system settings people recommend. So you might need to tweak the kernel, you might need to change your discrete settings. Doing those and actually picking the right, let's say, EC2 instance is very important because if those aren't correctly optimized, you could actually have sort of bottleneck in your computer. Again, it goes back to the monitoring. If you use CloudWatch and you use Prometheus and you're tracking your CPU, you can see if you're suffering at the disk level or the CPU level. This talk is going to take a particular view. I know we have another talk on notebooks later on, so I've kept it simple and just putting components. I know people use notebooks as one way of implementing these pipelines. Typically, I've seen successful customers use simple pipeline elements rather than the notebooks. They try to break down the pipeline into each stage being as simple as possible. So then one of the key things when you are looking at an operational pipeline is to try and take out complexity where possible, because the interactions between all of the stages are going to be complex enough. So sometimes using those toolkits are useful, but sometimes they add debugging walls if you're on the far end, and I've been on the far end a few times. Moving on quickly, I just wanted to throw this up. I'm going to refer to this a few times over this talk. This is kind of two models, two parts of a potential data pipeline. I've stolen most of this from a talk from Adro. It was another Dublin tech company. They gave something similar at the Amazon reInvent conference a few weeks ago. I thought actually gave a good example. So on the far side, you can see matrix model. So in that case, you load the data, you've got your loaded data, you're going to transform that data so you can build a matrix. One of the things you notice when you're dealing with machine learning, machines are great with numerical data. Very many of the machine learning techniques that I'll briefly cover, they like to see ones and zeros. If you give them categorical data, they get information. So there's normally a transformation stage. We'll cover that briefly in some of the code examples later. But when you do that, you can then build a model, and I'll talk a little bit about random forest and support vector machine later. And then you just apply that. But maybe continuously rebuilding those models. Might be an hourly, might be daily, might be weekly, but your pipeline needs to support that. But at the same point, you might be pulling things from a dashboard or dashboard. So that's what I mean on the closer side here, where I say compute metrics. So you might want to be keeping kind of scratch count of how many users you have, what you've sold in the last hour. So you can be looking at interpreting that data in several ways and building together a number of different products or services, as you want to call it. You can see within each of these, it's really just as the data moves through a pipeline, it's going in various states and various transformations or operations are being done. So you might be aggregating the data, you might be cleaning it, you might be moving into a matrix. That's all this is really just to try and represent. This is kind of something you might see in a typical company. Typically, if you're a data scientist, one of the things you might want to do is average a data set. So these are some numbers I stole from a couple of colleagues who've done the maths on it. But one of the things with Python is selecting the appropriate data structure. Generally, dictionaries and lists are general purpose containers. They have type checks, they have some other checking around that means they're really useful for your script for starting. But if you want to optimize it for production, you have to look at things like NumPy. NumPy is a scientific library. It's kind of moves from all of that extra stuff straight into C arrays. On top of that, if you start to want even more performance, you can compile that with the more sort of commercial numerical libraries like Blast, LAPACK, and Intel's map kernel library, the KL library. So when you go into production, you suddenly change from looking at doing what was your test script in the library into the factory. In the factory, you want to produce as much as possible. You want to be able to scale as much as possible. So looking at the numbers there, you can see that there's a couple of orders of magnitude performance if you're solely just crunching the numbers. So if you're a data loading stage, there's a bottleneck. Well, building your models are going to be slow, or building your dashboard, depending on if you're looking at the whole data set or what you're looking at. And I'm going to cover briefly here just a couple of the other data transformations. So one of the tools you get in Python is Panda. It's probably the nicest thing I've ever found in Python. And the reason I say that, I go back to what I said earlier, I'm somewhat an R exile. So the concept of a data frame when I'm doing my machine learning was just so dear to my heart. And once I got around the Panda library, I was like, yes, now that I have my foundation here, I can build from that. It allows you to do things like create the dummy variables, filter the information in a sort of familiar way. So I highly recommend it. I briefly touch on it later, but that is probably one of the most useful libraries you can look up. It's really just tooling around all of this and not really worth talking too much more about, but that's really useful if you are moving from something like R. Running back a little bit to MongoDB, the next part of the talk I'm going to focus a little bit about improving the speed of extracting and loading data from MongoDB, so you can push that into NumPy. After that, then I will look at a little bit at airflow, and then I'll circle back again. PyMongo is the typical way of accessing MongoDB. Because it uses some approaches I'll talk later, and I'm kind of covered with the dictionaries, it's a bit slow. You get about 150,000 documents per second, and you know what? That might be fine, and you might say, that's all I need. But if I'm looking at as fast as possible or getting more data when my data is growing out, you might need to look at alternatives. Monary was developed in the financial sector. It's another open source project to address that. So there's various people contributing to it. Some are MongoDB, some are outside. MongoDB is an open source company, and I think it's one of our secret advantages. Everything we do pretty much is open source, and it has really helped us as a company attract some really great people. They're very, very, very much engaged in all of those community and stuff, so let me talk about things. But Monary does almost 2 million, 1.75 million transactions. That's a big jump. So I'm going to just walk through a sort of an example pipeline using Monary, doing some simple aggregation in MongoDB, and then I'll move on to talk about workflow and scheduling and airflow. One of the things about MongoDB is the database itself provides a great aggregation framework. So people here, anyone here who's Hadoop or familiar with MapReduce framework? Okay. So the MapReduce framework is a way of dealing with embarrassingly parallel calculation, where you basically break it up and you set a discrete chunk of work to a worker. It all gets done, and then it all gets aggregated back at the end. Previously in MongoDB, you ended up using a MapReduce approach. It wasn't as efficient as it might have been. So people came and were asking, can we do some of the basic aggregations in the database? So that functionality was provided. And it's quite useful then that if you're calling that from the database, it's reducing another step. You don't have to go to Hadoop, which is also useful, because if you think about simplifying the pipeline, you're always trying to see what's good enough, how can I keep it clean, how can I reduce the number of steps, and how can I speed it up. I'm going to use the same example, and it will be the same example in the code in GitHub. There's we have a MongoDB University. It's free, it's online, you can get all your training, sign up. They do a couple of modules every quarter, does 6 or 7 programming languages at this stage, and some just administration stuff. But one of the things we have from that is a whole pile of data sets. One of these is the ZIPS database, and it's a very simple database. In the back, I'm not sure if you can see it, but literally it's a collection of data about US cities, their location, their population, and which state they are in the US. So that's it, that's each document, that's what auto represents a different city. So just to go down to the bottom part of the slide here. So this is the pipeline. If you've used MongoDB before, you might be familiar with the Mongo shell, which is the console within the database. It's the exact same pipeline command you'd use. All this is going to do on that data is group each of the documents by their state, which is the dollar group. And then it's going to create a new field for the population, which will be the sum of all the populations for that for the cities of that particular state, and then aggregate all of those together and produce a number. That's all it is. It's not a very complex, in some cases it's not really a realistic one, but it's a nice simple one to walk through. So before I dive into how you do that in Monary, I just want to take a moment to explain a little more about why Monary is a little bit more performant. So Monary is basically two things. It's a Python wrapper around a little C program, which then calls the C driver, MongoDB C driver. So the first stage here is it just goes down to C Monary, formats that in the appropriate way for the C driver, which is the C Mongo, which is 3, 2, and 3 there. That calls the database, goes back to the C driver, which is smart enough to realize it doesn't actually have to go back to that extra stage. One of the things I would like to flag, and I found it as a sort of side note in the pull request. If you're using a larger data set, so the data set I have is kind of a toy data set, but the aggregation framework of MongoDB in sort of the more recent versions has a limitation of 100 megabytes, but you can normally use a allow disk use flag. So what you need to do if you are going to have big data sets, I'll have it in the slide notes. There's a pull request where you basically add 2 lines to the Monary C file and recompile it, so you can deal with larger data sets. At the moment, there is no pull request to incorporate sort of named arguments with KWRs in Monary. That should be there, I think, in the next major release. Just that was one thing I hated. I tried to use bigger data sets, but you can hack around it. So, typical Python console, loaded Monary, ran the pipeline. I'll walk through these steps now, but literally it's 1, 2, 3, 4 lines to generate the output for this. It's quite nice little useful tooling. So the first thing, what's the most important thing? The database. You need to be able to reference the database. The next argument after that is the particular collection in the database, and after that is the pipeline. However, if you've used MongoDB before, it looks a bit different. And it looks a bit different because it has things like the field name and the return type. At the moment, you need to explicitly tell Monary if it's an integer, if it's a string, so that the C driver is told how to format the data as it's pushed back. They're changing that, and that will probably be fixed also in a later version. But for the moment, those are sort of the catches if you're moving from MongoDB to using Monary, or PyMongo to using Monary. So just to kind of show this as a result, it's kind of maybe hard to read even here. So I just highlighted a few things that I'd still say it's very hard to read. But the top line there for this data set says there's about 30 million people in California, just over 12.5 in Florida, and then 18 or so in New York population-wise. So that's all that did. It grouped all the cities by state and just summed it up to give that figure, which might be useful now if you're looking at doing a dashboard. Maybe you want to do that aggregation. Maybe that's all you need to do with your data. Present that as part of a service. So at this point, I'm kind of going to move quickly to cover some of the tooling and the pipeline and the systems. There are alternatives. So, for instance, there are alternatives to Airflow. One that I speak about briefly is Ouija. There are also other, I think there was a workshop on there about Broken, and there's Seaborn, and there's other visualization libraries you can use. with Scikit-learn. For every tool I mentioned here, app or database, there are anywhere from 2 to 10 open source alternatives. This is not.
That should be not fun.
Yeah. Sorry, I was speaking on slide last time. But for every one of those, there's a whole host of other ones. Depends on your own environment, what your team are familiar with to use. So this isn't written in stone, this is only just an example. Looking at, or moving back to address some of the actual requirements for an operational pipeline, you need to be able to schedule it. It needs to be repeatable. So if you're looking to build a model every hour, every day, if that model has dependencies, so if I need to build that model based on certain data, that may need to be aggregated further on, or may need to be loaded to be fresh and have the latest data. Looking at the monitoring, I spoke a little bit about Prometheus. It depends. You can use whatever monitoring tool you want. One of the things we say for MongoDB is we have Cloud Manager and Ops Manager, which are specifically around the database metrics, so you can set alerts around that. But whatever monitoring tool you're using, it should be able to send you email alerts if something's failed. You might link into PagerDuty. You might be looking at aggregating stuff through Relic. I guess I should mention your application is one of the sponsors here. But all of those need to be considered, and you need to think about those. One of the things that we've seen a change in more recently is checkpoints are the concept of taking a snapshot of state at a moment in time. So it's kind of a familiar thing if you're used to maybe the scientific computing or the high performance computing with Python. If you're doing a very large calculation that takes quite a long time, one of the things you want to be able to do is, after a number of steps or iterations of that model, stop, take a snapshot, have that and continue. Because the worst thing you can do is have a pipeline where you get halfway down through it, it crashes, and you have to go back to the start. So checkpointing is an important thing. Whether it's just keeping sort of temporary file at the end of each stage of the output, or it's actually checkpointing. So for instance, things like Docker now have seen this as a big thing and are implementing checkpointing in their container solution. So I think their demo is quick, so you can play a game of break, stop it, and resume exactly where it was. But it also has more interesting and useful production uses. The last point is actually really probably the most important. You need to be able to manage the dependencies. So what do I mean by dependencies? They could be temporal, they could be A, B, C, so A happens first, then B happens, then C. Managing all of that previously was quite complex. So in the old days, there was cron. You would write everything. Some people still use cron all the time for this, but it doesn't really handle some of the conditions. You want to make sure that it's not just fired every day or every hour or every whatever. You might say only fired if these other conditions have been met. Or you might want to trigger based on other rules if something else happens. This has been a really, really, really important sort of realization for quite a number of companies. So Pinterest developed and released Pinball. Spotify developed and released Luigi, which is another Python scheduling tool. All of these companies were trying to orchestrate.
Can you comment on any differences, or are they like the same?
I'm not as familiar with Pinball, but one of the reasons I chose Airflow over Luigi, which would be another sort of well-known Python workflow environment, was that you were extending classes in Luigi, which is fine, but I just thought writing clean models in Python for Airflow was something I felt more familiar with. And to be honest, the installation was such a breeze with Airflow. I went, oh, this is so simple. I don't even want to look at something else. That being said, Luigi 2.0 was released last night. I was quite annoyed at some of the new features in it, because I thought, shit, they're really cool. And Airflow doesn't have those, so they released two particular features where they would deal with the jobs, sending them to EC2, but also sending them to EC2 with SunGrid Engine. So anyone here who has experience in maybe the high performance computing side will remember SunGrid Engine or batch-based processor. When you go to large scale clusters, one of the things you do is you basically have a batch scheduler. That takes all the jobs, carves them up, and puts them together, and utilizes your hardware. So it's a very important thing if you look at hundreds of EC2 instances, making sure if you're running all of those at any one time, that they're full, or they're as close to full as possible. That's something that these tools are beginning to do, to send the jobs to that. So yes, I might, if I was to look today, I might change my mind.
The disadvantage of the open source world is there's always something new and better.
Yes. Like there's also, I haven't really looked at it, but there's Mistral for OpenStack. So I'm going to run through quickly here before I don't have a few more minutes, but I want to move on because another few slides cover out some actual code, not just me ranting. This is the screen you will see when you install and load Airflow. You can load it from pip. There is a great Python document site. Support the Python documents project if you haven't already. It's a very useful project. It's under supported. Give them money. There, I think it echoes the talk earlier in the room about test-driven documentation. Documentation is really useful and very much undervalued. So open source community sites that support all of your really useful projects. You know, if you have a few dollars or euros or pounds, you know, that's something that probably never gets the proper funding to it. Looking at one of the reasons I said about Airflow is you just develop it as a script. And I developed a couple of them. One was an example operator with Monary, and one was an example with Mongo. And it's literally, you just code it up and I'll walk through some of the examples in a minute. The interface itself, if you click down into one of those workflows, you get two sort of different views. You can barely see it on the far side there, but that's a direct acidic graph where you have those dependencies managed. You can say, this task happens, then these 10 tasks can happen, or then the next task can happen after those 10 and finish. So you can define a workflow like that. You can also look at very simply as the code. So both of those are kind of similar tasks. They're really only one stage with a second stage of sort of 10 similar actions. But you can see the code and go in and change that and upload it to the UI as well, which is also useful, so you can tweak it as you go. So a little bit of code, finally. So this is a little sample script I wrote for Monary. And again, it just uses the pipeline we talked about earlier. Very standard. Everyone, I hope, or if you're not, if you're new to Python, this section at the top is basically importing the various libraries you need. The next section is looking at a couple of the settings. So you can set something to be scheduled from, so when should it have started? So in this case, the tasks I wrote, jumped on right now, I said they should all start 7 days ago. So once I added them in, they would immediately start running. How often should I repeat them? In this case, it was once. How often should I back off if it fails? Which is also a useful thing to say. Maybe I don't want it to run if it fails, maybe I do, maybe I want to keep on running. You can also add things like email, so if it fails in the email, which is quite useful. Depending on the various stages, you can tweak that with extra information in the email as to what happened and what went wrong. The next few lines here, basically all you need to do is define this directed acyclic graph. You need to give it a name and some arguments. Yeah, I'll go down and show the arguments, which are basically the function. Next slide. So literally, that is exactly the same function pretty much I walked through with Monary earlier. The same zips data set, aggregating that, getting the sum per state of the population. And then it just returns that result. To call that function and set it up as a directed acyclic graph, you use a Python operator therefore. You basically say what's the name of the task, what function am I going to call, which is one on the top, and then associate it to the sort of root object. And then
go to the next slide. It's a very simple, 10 sleeping tasks, sleeping for a random time. But all you need to do for the next task is that last line here. So you can say set upstream of. So in this case, I've already defined one task, and then I'm saying this should run after my aggregation task. So very, very easy, very useful then to set up those complex tasks with the dependencies as to when things will run. The output is it's just a console output. Therefore, we load all the tags into memory and just print out the output there at the bottom of the screen. You can also do some other interesting stuff with the aggregation framework. So here's a later one I did, and this was one of my own sort of Apache weblog data sets. So what I use the aggregation framework to do is basically create information about the pages visited per day and keep a count of those. So maybe I wanted to do a website report. In this case, I did a very simple export. There's one of the things at the moment for some of these, and I know I've taken it to do, is there's no operator for transferring it from MongoDB to other parts of the pipeline. They do have operators for things like MySQL, for HDFS, Hive, so you can move that data naturally through the schedulers because they've already got the functions there to manage that. So it's one little bit, so I had to do an extra export stage. But the aggregation framework gave me basically the day, the month, the year, just the name of the page, and how many visitors or requests for that page occurred on that day. And you can use that to build up a web report for that page. It's, again, just another simple example, but it's a useful way of saying, I'll just go back. The last stage of that operator, the aggregation framework, has a really neat feature. It allows you to output the results of an aggregation to another collection in MongoDB. So you can do some fairly complex operations and then just say, store it in that collection. So moving along from that into moving away from the MongoDB, moving now into the section on pandas, which I love. Matplotlib without the H. And just visualizing that. So it's one of the important things when you are in the lab side of machine learning group or machine learning department is that you look at the data, you analyze it visually. When your pipeline is being prototyped for the first time, it's very important to look at the different stages. You may have introduced an artifact into it, scales may have been wrong, you may end up that something was changed. So MongoDB is a database that allows you to have multiple parallel schema at any one point. So as your schema evolves, you have to be careful that your pipeline evolves with it. You might be missing information, or it might have changed. So that's one of the other things that's implicit in keeping an operational pipeline up to date, is making sure you're also tracking the changes to your data. And sometimes adding stages where you maybe not for end use, but just for your own QA and validation, is you have a little bit where you generate some graphs and you just review those, because you might also have, in some cases, if you're operating a data service, you might be hacked and you might suddenly realize that people are pushing lots and lots of requests of a particular type through your service. Maybe your monitoring will catch that, maybe it won't. If it looks valid, maybe your monitoring won't trigger. So looking at visualization is very important, even in the production side of it. Normally people will say that just for the investigation, the exploration. This is just a little bit of sample data I stole off the web. Everyone here have a mobile phone? Yeah, I guess so. Telcos are very much interested in not being data pipes. One of the things they want to know is what they can upsell you and if you're going to change. So if you're O2 or Vodafone, I saw Shane here. Shane has a great product which allows you to pick the proper mobile operator, and it does a lot of cool machine learning. Probably has a data pipeline like this on it. It's another good Irish startup which takes this kind of information and in his case it looks at the best plan for you. Telcos have this information, how what plan you're using, if you've called international, how many calls, what you've spent, and they use all of this to determine actually will you still be a customer next month, next year. If you're not, you've churned, is what they say. So churn is a very big consideration for these guys. They don't want to lose customers. This example, I've started to use some of the Scikit-learn. Again, similar enough. I'm going to cover very briefly some of these models. I'll direct you to some other speaker decks I have that'll expand on the machine learning side. But literally, the random forest and the support vector machine are the two I use in this. I just took in that churn data, it was in a CSV file, used pandas to manipulate it a little bit, and load the data and explore it myself, again, just looking at the data, formatting it, dropping out some of the columns that weren't too useful, including their view on churn. One of the things, if I'm building a model with a predictor variable in there already, I don't really need that, so I'm going to drop that. And then basically looking at the feature space and transforming that, looking at how many observations I have and how many different features. So the observations are basically each customer record, and the features are basically if I have an international plan, how much I spent. Each of those is just one of the columns really. I used threefold cross-validation. I had an old image with tenfold, so forgive me, I stole that instead. One of the things you will do to improve the robustness of your machine learning is to train it. And not just train it on Typically, you would say, I'm going to keep 20% of the data aside, and I'm going to use that to test my model afterwards. And I'll train it on 80%. But what you can do is actually change where that 20% is. So in this case, it's tenfold cross-validation, where I split the data up 10 times. So the first time I take, let's say maybe the last 20%, and I move down through the data and use that for one iteration of the model. And then I use that to train my model. So I get much better value out of the data set that I have. And it's one of the techniques you can use to improve the robustness. The other technique you'll often see is where people use multiple models. So I first used a support vector machine. I'm conscious of the time, so I'm going to move on kind of quickly through this. And a random forest. Random forest is really only an iteration of decision trees where you kind of look and split it randomly at the bottom and try and get the best predictor at that level and then go down to the next level. I leave that for the moment just to go back to this. We can spend 40 minutes talking about machine learning another day. Those are two of the kind of popular models you'll get. The code here takes that data, runs across validation on it, splits it up so you get a bit more of a robust data set to train your model on. It then trains it on a support vector machine and the random forest. And this is really simple. There's not even, if I took out the print statements there might be 10 lines of code there. Scikit-learn is a really powerful framework for building up these machine models. You can then embed this with things like Airflow. So you can have these in your operators in Airflow. So all of a sudden, each of your stages can be building models. So just start to wrap up here now because I'm kind of getting out of time. That side there looked at the machine learning side, so it was the matrix building that. The aggregation side I covered earlier looked at building the dashboard or computing the various metrics you might have. Covered a few different things. I've focused a little bit on Airbnb's Airflow tool. You can use Luigi, it depends. As Peter said, they're changing all the time. You should look at it the day you go to do this. Literally. Airflow is really powerful. It allows you to alter those workflows, visualize them, set the dependencies, manage the repeatability and the schedulability of it. It allows you then also to troubleshoot that and maybe alert you via email. So it covers off those requirements. One of the things I would say, each of these will move, if we came back in 12 months' time, there will be a whole host of these tools. Companies, this is very hot area. People might be familiar with an aside with Mesos. So linking all of these tools then into schedulers is probably the next area where things are going to go, because as I kind of mentioned earlier, putting all of these pipelines together and operationalizing them is a competitive advantage. People might have heard of the org scheduler and Omega from Google. That was where 10 years ago they said that was their competitive advantage. We are only now really getting to those tools.
But undoubtedly they're their major companies, right? It's just we don't have open source version of that.
Not yet,
Yeah.
but hopefully soon. So I've covered PyMongo, I've covered Monary, I've covered why you should investigate Monary if you're using MongoDB, and I've covered why looking at NumPy versus dictionaries is important. Not just the speed of your pipeline, but also if you're training your development team, your analytics team, if you can do a pure Python solution, you can have the people in the lab using Scikit-learn, you can have them using Airflow, you can have them working with the ops guys and the other computer programmers who are on your factory side. So Python is one of the underpinning glues that brings all that together. And as it stands at the moment, it's probably the best tooling available out there for you to productionize your data pipeline. And so I just wanted to say thank you to everyone on the internet who I robbed your photos from. And take questions.
First question? Your hand up.
How do you, just as a matter of interest, how do you differentiate traditional ETL system from Python? Because just in terms of what you discussed there, I see a lot of overlap between traditional ETL and Python, and I'd just be wondering how there are decisions to go in ETL versus one to use Python.
So the question is how you differentiate between an ETL tool and the pipeline.
I was actually at the Reactive meetup recently, and I saw the noetl.org site. So one of the things, all of the tools I covered here are open source. Airflow allows you to dynamically change that pipeline, so you can change that for various circumstances and situations. You can pull in different tooling. In essence, you are taking data, you are loading it, you are moving it through a set of calculations. You can do that with one of the traditional ETL tools. The fact that there are more companies who are using these tools, the scheduler tools and the pipeline tools out there, would suggest that actually when you're trying to embed both the machine learning, the stuff that will be developed in the lab using these Python tools into production, that the ETL tools out there aren't a good match. And they might be adding extra stages. So one of the things I said, if you can do aggregation in the database, do it there. One of the things about an operation pipeline is you want to take away stages where possible. Don't do something unless you need to. If you're transferring data, if you've got Pinterest, Pinball, processes, I think, 4 petabytes a day for their models. If you are just loading 4 petabytes and you haven't it staged, just disk read of 4 petabytes might take the day if you've slow disks. You need to work all of those practical considerations into your pipeline. But overall, I think the fact that you can have a unifying language and some very easy to understand code that can be shared between those guys in the sort of the lab group, the research group versus the operations people, that it gives a common language.
Is it that the productionization, is that the issue? It's more difficult to productionize an ETL solution versus a Python?
So I would also add that most ETL tools were not designed for kind of the Hadoop kind of HDFS and all these other things, because Eric Bernardson is one of the lead architects for Spotify, and he said it was basically for what you're saying, right? Our problem is, how do you build a good recommendation engine with a petabyte of data per day? It's only a problem that firms like Pinterest and Spotify have run into.
Or your next successful startup that leads from here. No, it is a fair point, but ETLs came about in one sense when we were in the era of relational database. Now I'm not going to jump up and down for NoSQL, but the fact that you can have dynamic schema in your database and you can have multiple concurrent schema held in memory. The fact that MongoDB isn't the only one React was next door. They're in memory. So you're not moving all of that data through the disk up, warming up memory and moving it through. You have to look at that. 4 petabytes is a hell of a lot of information. even today with the whole idea of RAM-based clouds and using everything and keeping it just in RAM. It was a tooling for a different time when relational databases were more rigid, and you needed then the flexibility, whereas, just speaking from my own experience now with MongoDB, you can have 4, 5, 6 different schema versions in the documents in your database, and still work with those. So there's flexibility there that as your business develops and you add new fields, you don't have to also re-edit your ETL pipeline. Okay, like I said, you should continuously review it, but if you don't have to, or if it won't break, it'll still work. It might give you all the information out that you want, but then you tweak it to do that, but it doesn't break down in production. That's an important point.
Well, thank you very much, Eoin.
Thanks, man.